we do for this drill and understand major diameter, minor diameter, internal threads, and then how the external threaded part goes in that hole and how to represent that one, the difference in the section lines. I don't want to talk about it again. Then after that, we have this representation of the bolt and the nut, which again we have done in the lab. This is a manual method they are telling here. Uh, we didn't discuss this one. So lock nut and the locking devices, because many times the threaded fasteners are there on the vibrating or moving parts. Because of the vibration itself or because of some forces acting on them, they may get loose. And so there is something, a liquid also called as a thread locker. They put like a glue on the threads and then fix it. So it will help it to hold it there. As well as there are some mechanical locking devices associated with the threaded fasteners. So these are the different examples of the locking devices. Then we have these different examples for the machine screws or the cap screws. We already are drawing the cap screw with hexagonal headed bolt, and all the dimensions here for the cap screw of the hexagonal headed bolt are as we discussed and as we have drawn. 2x3D is a bolt head thickness. We get this side for the hexagon from the top here in the hexagon, and so on. This is here schematically represented. Okay, this is here schematically represented. The major diameter, minor diameter, and everything else is specified here. Apart from the hexagonal head, there are other heads also, but we don't have to. Somebody's typing something. We don't have to. Attendance, you tell me at the end of the class, okay? Those who are joining late, understand, but we'll not talk about it now. Apart from the hexagonal headed, there can be a different, actually there are tens of types of the heads, okay? So, and we cannot memorize all the specifications or the formulas. We are just memorizing it only for the hexagonal headed. But suppose it is flat headed, then there is also, you can see the angle is specified, the depth of the slot, width of the slot, everything is specified. And all these things depends, they are in proportion to the major diameter, as you can see here. This is specified by the ISO in the thread handbooks, and the manufacturing companies of the thread manufacturing company, the screw manufacturing companies, they follow the handbooks and they make as per their market reach a type of the threads. And some are in the specialist threads only, some of the company just make a general type of the threads. So they will make it as per these specifications given, and this is these dimensions here given from the specification of the ISO handbooks. Unfortunately, ISO handbooks are difficult to access. They are very expensive. They are not because it is for commercial purpose. So I cannot even find some samples, but these are the drawings, and a real handbook sample we don't have. These are the drawings, and then we have certain tables also for that. Round headed, Philister head, and hexagonal headed socket for the Allen key. So you can see even for this one, how much is the width, how much is the diameter, how much is the radius, slot depth, everything is coming from the ISO standards. I'll move on. I just want to see and appreciate the fact. These are the different types of the screws. Machine screws. Again, the standard specifications are given. Now I want to ask you one question. Yes, yes.
Rahim.
What is your question?
Here.
You are here?
Yes.
Oh, thank you very much for coming for the class. Now listen to what we are talking about, and about the attendance, you tell me at the end of the class, okay? Everybody, those who are joining late, no problem. If you stay up to the end of the class, then I will, at the end of the class, I will repeat again the attendance and the number. But you have to stay up to the end of the class and listen for that, okay? So now these are the standard machine screws, and you can see here some dimension. I have a question like M8, if you can see my cursor, M8 into 1.25. What is 8 here? Major diameter. Metric thread, 8 is a major diameter into 1.25. We have seen that one. 1.25 is the pitch of the thread. Okay, this is the value of the pitch into M8 into 1.25 is the pitch, like this. Then standard set screws. Again, we don't have to, like, we just are looking at the different types of the screws, and still there are more types. The wood screws, They are tapered at the end. We don't worry about the wood screws, okay, generally. And these are the miscellaneous bolts and the screws. As you can see, the stow bolt, another type of the stow bolt, collar screw. It has a collar here. Generally, most of the screws will have the collar here. So it's like replacing the washer or inbuilt washer attached to the head of the screw. The hanger bolt, it is kind of having a thread again at the end, and it's like a stud actually. The lag screw, the step bolt, here it is a step, and then it is increasing in the diameter, or it is now in this case it is a maybe square thread, square cross section and going in the particular slot, so that it is difficult to remove it. You need special tools to remove it. Drag bolt, and different types of the bolts are here. You can see the turnbuckle. The turnbuckle has left hand threads and one side and right hand threads on the one side, so that if you move the body, the distance between the heads will vary, because they will both come in or both go out depending on the direction of the rotation of the body of the turnbuckle or the socket of the turnbuckle. It has one side left hand side thread, other side right hand side thread. That is and the specialty of the turnbuckle. Then we have the thumb screws for the light applications, like in a water bottle caps. Yes.
The last one, the turnbuckle, when they use it?
Okay, it has many applications. Basically, the applications where we want to increase or decrease the tension between the cables, wire cables, or in any machine parts also you can see.
Yeah.
So it has a eye bolt or a different type of the end here. This is eye bolt, okay, eye bolt kind of the end here, and on the other side also. Then in generally it is connected to some cable or maybe some machine mechanism. It can be a lever also. So what you do, you want to increase the tension, you turn the body of the turnbuckle. So because one side is left hand, another side is right hand, the both will come in or both will go out, to increasing the distance or decreasing the distance between the two fixed points of the eye bolt, you can see. So it is basically for increasing or decreasing the tension. Usually you will find it in the tent applications, also for the some like in the like for example, if you have some trunk like thing, you want to, like a Jeep Wrangler, the hood, you can have the turnbuckle there for in attachment. You can turn it to make it tight there on the hood, and if you want to lose and then open it like that. Basically for locking mechanisms, or for basically to increase the distance between the two ends of the head here. That is the main thing, function achieved by that. It can be very strong. You can see in front of the ACX building also, there is a kind of a tent or the shade, that also at the end you have the turnbuckle. So you keep it loose little bit so that you attach it, and once it is attached and once it is fixed, then you can use the turnbuckle to make it more tight because it should be stable in the wind. That is the reason. The thumb screw usually for the light application, you might have seen it in the water bottle caps. Wing nut also similarly, where you have to frequently open and close and not much force is coming on that bolt, and then we use a wing nut. The advantage is you don't want to go for any like a spanner or the screwdriver. You don't have to go for using any tool. Just by hand you can operate it. This is the advantage of these two. And then the T-head bolt, it goes in the machine slots, as you remember, to fix your vise on the T slot on the drilling machine or on the milling machine. They use a T bolt. They have different kind of the shape. This will match with the slot in the table, and then you fix the vise to the table. Like this, different applications for different types of the. We just want to see the names and we should be able to identify it. We should be able to identify the bolts. Ahmad, I don't understand Arabic. Want to say something to me, or you want to say something? Are you chatting with your girlfriend? By mistake, you are typing here in this window at the same time. The voice is not clear. Is that the voice is
clear? But for him, maybe he had.
Yeah, maybe internet speed. His internet speed maybe in the law. Anyway, we have to live with it. Basically, we just have to look at and understand these things. Then we have the keys. The keys go when we have the shaft and there is a gear on the shaft. We want to lock the gear with the shaft, kind of thing, or wheel with the shaft. So and this is a Woodruff key, kind of a special, like a semicircular. It is less than the circle actually, semicircular key. Sometimes to decrease the distance, if the shaft diameter is less, you can have a flat at the bottom. But the advantage of this is when you insert it, it will not slip off automatically, because you have to move the wheel. Suppose this is a gear or the wheel halfway up to here, then you can rotate and fix the Woodruff key there. This is just type of the special key. These are the non-threaded fasteners. Some pins also are there. Their pins also are non-threaded fasteners. Rivets also are there. Rivets are permanent joint, but once you break it, it is done. And they use a hammer, press hammers to. It is generally the rivet is made from the again softer metals, so that it is easy to reshape. And these are different rivets, different shapes for the rivets. The springs, you know how to represent this spring. We have seen it. This is the orthographic and the sectional view of the springs, but the spring can be represented just by a line diagram, right? You know that. We have seen it in the first module. So that's it for this module. Now coming back to your question, which were in the third module, which is at the beginning of the third module, and also it is talking about the assignment question. Now what we have to do for this assignment? These are typical assignments. Another type of the question we have seen before. Say this is one. I don't know. We are asking 4.1 or 4.2. We will draw the same which we are asking in the quiz. 4.2, we are asking 4.2. This is what we are asking, 4.2. So we'll discuss this one. Also, we'll discuss the previous one, no problem. Also, we'll discuss this. What is the question here? And the question says, study the given views of the quarter joint elements. Element means part. The part drawing is given. And we want to make a sketch for the sectional front view for the assembly. And if part drawing is given, from that we have to draw the assembly drawing. Front view and the side view and so on. We have 4 types of the questions. In this course, we have 4 types of the question. The question and there is an answer. Question is part drawing. Answer also is part drawing. We just redraw. This is just redraw. Question is assembly drawing. Answer also is assembly drawing. Any answer also is assembly drawing. Answer also is assembly drawing.
دكتور
Future.
يا شباب الدكتور طلع كان الصوت انقطع.
ايوه طلع.
You can say they are more difficult also, because you need some thinking here in this type of the question. Part drawing to assembly drawing. How to convert part drawing to assembly drawing. Assembly drawing to part drawing, we have some exercise later on after the midterm exam. Yes?
Before the screen was it's closed. You are out of the this. You
Okay. I will restart it again. See, some students many times they are going in another room. So when you go for the session, there are many sessions here. The list of the sessions. You should see the date and join that. Not like you go here. You see the date and then go into that session, but that current date. And this is just another point. Now we come back to this question here. How we solve this type of the questions? How we solve this type of the questions? What is needed to be done? This basically needs some imagination, some thinking. These are the thinking questions. These are more than drawing. These are thinking questions. First, we have to read the drawings, read the given part, understand the shape. Now, sometimes only one view is given. Sometimes two views are given. Sometimes more than two views are given. These are the very simple parts. So here only one view is given. This is a sleeve. Only one view is given. Why one view? It is written diameter 25, diameter 44. That means it is a cylindrical part. It's like a pipe, you can say. The name of the part is sleeve. So for this kind of the parts, no need side view. The diameter symbol here tells that the side view is a circular. So no need side view. Then the two rods are given, and we have to understand the shape of the part. Then we think about the how to assemble them. Then we think about the dimensions also. Now there is a diameter 25 hole in this part. Diameter 25 hole in this part. That means this diameter of the rod also is 25, and it is maybe not clear here in this drawing. We can go to the original drawing for a while. Yes. So diameter of this is also 25. Whole diameter also 25. That means this part should go inside this. Also, you can see there is a slot for something. There is a hole here. There is no section line. That means there is a hole. Also, there is a hole here. And this is matching here. Then from the other side, the other rod is going in. So basically the sleeve is there to connect these two rods. Maybe their intention or some force is acting on them. This is to hold them together tightly, the sleeve. And then to lock it together, they are saying quarter 2 off. What is the meaning of number 2? Sometimes they will give the table at the bottom of the drawing. Now here table is not given. They are saying there are two pins. So the pins will go inside that. The quarter joint. The assembly of this will be something like this. And it is very commonly used parts. This is single quarter joint, maybe double quarter joint is this one. Yes. Yes, please.
There was a problem in Blackboard.
In the audio?
Yeah, I'm sorry to be late.
Okay, no problem. No problem. Okay. But now you can hear me, right?
Yeah. 144, my number.
Okay, we'll take the attendance. Once I take the attendance in the beginning, those who have some problem in joining because of some technical issues or whatever, at the end of the class, you tell me about your attendance again, okay?
Okay.
Okay, no need to interrupt the class once it is going on. So the quarter joint assembly, we have to basically, sometimes what happens here is, it is a thinking process. This is a thinking process to solve the part drawing to assembly drawing. So first we look at each part drawing, understand it, then we look at the dimensions and see which part goes in which hole. And if there is a hole of diameter 20, there is a pin of diameter 20, that means that pin is going in that hole only. Also, there is something called as full proofing. When they design the parts, they do is foolproof. Foolproof for assembly. What is foolproof? What is the meaning of the word foolproof? You know the meaning of the word fool, huh? The fool. Fool means what? Foolproof means what? Yeah, full means what? What is full? What is the meaning of this full? This is not FULL, okay? This is not this FULL, okay? This is full. Full means breakfast time. What is this full?
Stupid.
Yeah, this full means stupid person, okay? Full in the sense, it is in the line sense, lighter sense they use it. It is a stupid person. What is means we are likely to make mistake. So parts are designed foolproof. Now the meaning of the waterproof, dust proof, heat proof. That means it is against
Yes.
that. Yeah. So like that, this foolproof means the designs are foolproof in the sense you cannot make the wrong assembly here, even by mistake. They choose the dimensions cautiously so that somebody, when he's assembling, he's not allowed to make a wrong assembly. Like once you buy PC from the market or online, monitor, keyboard, CPU, everything is different. For example, when you want to assemble, you will see that the monitor cable will go only in a specific slot, the keyboard cable will go in the specific slot, the power cable for the CPU will go in a specific slot, the power cable for the monitor will go in the specific slot. They change the size and the shape of each of these pins to make it foolproof so that nobody makes a wrong assembly. This is one very simple general example of the foolproofing. But even in the mechanical assemblies, now for example, we'll have a look at another exercise, which is here only, this exercise, which we will cover in the lab in the coming days. You can see here. Now there is a hole of diameter 25. This is a pin of diameter 25. So this pin should go in that hole. That is the meaning. There is another small hole here, diameter 6. So there is another pin of taper pin of diameter 6 that will go in that hole. If there is a hole, there is a specific. Suppose there are two holes. Now, unfortunately, we don't have the two holes in that part. For example, you have some part like this. Let me get some shape here. Okay, this is a shape, and there is a one hole here at this place. Say there is one. This is center line for the hole, and this is another center line for another hole. Okay, if there is a hole, for example, this is a hole here. Okay, hidden line. Assume that is a hidden line. This is a hole here, and a pin should go in that hole. Okay, a pin should go. Suppose a pin should go in that hole. If it is okay, now there are two holes, means there should be two pins. If it is okay that the pins are interchangeable, then they will keep same diameter for the two holes. But if they want this pin to be different, and this pin there is not the pin, something else should go in that hole, then they will intentionally keep the diameter of these two different. If it is okay to interchange, they keep the diameter same. If it is not okay to interchange the position, then keep the diameter here same, keep the diameter here same, different, so that somebody by mistake will not replace like this part here and this part here, because there are two holes. So this part should go in this, part A should go in this hole, or part A should go in this hole. There should not be any confusion. And if it is okay to go here or here, if they are exactly the same part, then they can keep the same diameter. Otherwise, they keep the different diameter. That is called as a foolproof. So in our assemblies also, when something is matching the dimension, you can directly, without thinking, put that part in that hole. But if the diameter is not matching, don't put that. And there is a hole and there is a pin, you want to put that part in that hole, see that the dimension is matching. Dimension must match exactly, and this is what we have to be careful about. Now, how to draw this? How to the solution for these kind of the things? One way of doing it is we start with the largest part. Draw the largest part, copy the largest part as it is. Suppose you are doing it in the AutoCAD, I will draw this part as it is first, and then I can draw this part in that. Suppose many times you will have the parts like a base with the name like a base, or the frame, or structure, or maybe bed in case of the lathe machine, say bed. So I draw these large part first, and we draw the or we can say redraw the largest part first, and then put or fix smaller parts around it. This is what we do the part to assembly drawing. Redraw the largest part first, and then put the smaller parts in that hole. If there is a hole, there is a slot, put that smaller part in that one to make the assembly. Also, when you are making the sectional view of the assembly, the neighboring parts should have a different direction for the hatching lines. Now I'm stopping the sharing for a while, and then I want to open some file.
Teacher, can you
Yes.
go back to let's draw?
Go back in the
Last sketch, teacher.
okay, 1 minute. The one which we have for the assignment. And these drawing with the parts which we are discussing are typically used in the design calculations, to learn the design calculations, how much should be the force, shear force, tension force. This is a typically good example to talk about those things. Yeah, I'm trying to share my screen, but okay, there are 32 now. Also coming back to your question, okay, you wanted me to show this. Can you see now? You're talking about this one, this example, right?
Yes,
Which we have to, yeah, this one, yes.
This line 25, and after it, how much size?
This is 25, right?
Yeah, after.
And after,
How
after
the
that,
size?
how much? Okay, okay, it
Yeah.
is not given. It is not given. See, now what you will do, how to get that one. You have this part 35. So it is starting from the middle of this, okay? This part is starting from the middle of this. Let me get back to the this one. So this part, one part will start from here. Suppose I have the proper thickness, okay, of the line. Okay, it is starting from the middle of this part. They are middle, in the middle, they are meeting here. Okay, now one part is like this, and then it continues this side part. The other side part also similarly will continue like this. This is a taper. It goes like this, coming down like this. It goes here. Then you have this part, right? How much is here? This is 53 from that end, 53. So go from here 53. It will come somewhere here. Okay. Don't worry about, and this is 25 from this end. How much is this? We don't know. How much is this? We don't know. What we will do once we have this one, we put this part there. Keep it the center of this part aligned with the center of this line. So you have this part here. When you draw it like this, it will go inside this. I'll show you the assembly drawing directly. Picture. Okay. Yeah. So it will be like this, a quarter joint. You have the sleeve outside, then you have these rods inside, they are touching in the middle, then follow the dimensions of the rod. Then you put the quarter pin. Understand that the quarter pin is having some clearance here. Clearance. It can be 2 millimeters, 3 millimeters. That's why those dimensions are not given. Now, why the clearance is shifted on this side and here the clearance is shifted on this side, that 3 millimeter clearance. What happens is when these parts are in action, this is a force P pulling this rod in the left direction. So when it is being pulled, this, because the hole in this part is larger than the size of the pin, so this will touch here to the quarter pin and the clearance will pass on this side. Now the rod is pulling the pin, so pin also will try to go in this side. So the pin will touch the quarter joint here, and the clearance is shifting on the right hand side for this pin. Exactly same, our opposite is happening in this side. This rod is pulling it in the right hand side. So this pin is touching here, the rod is touching the pin here, and the clearance is on this side here. Whereas this quarter pin is being pulled in the right hand side, so it is touching here. Whereas there is a clearance of 3 millimeter, whatever dimension remains here. You can take an approximate value for the clearance there. That's why the dimensions are not given in that case. So this is an approximate solution for your question. So when you draw it, the question says you have to use scale 1:1. What is the meaning of the scale 1:1? Use the instruments. Like if the diameter is 25, it should be 25. Looking at 25. When I measure it, it should be 25. If the diameter is 30, like follow the dimensions given here in the drawing. If this is 44, it should be 44. This is 150 length, it should be 150 length. Follow the dimensions and draw it. It's very, but try to make neat sketches, good quality sketches. That's it for today. The other question is 3.1, which already is given, and the major diameter is given in the question. So it is like, it is about this question in the assignment. Yeah, this one, right? Redraw. So understand this one, what you are drawing. It is important. Also from the exam point of view, to understand the difference between the various fasteners, what is a nut and the bolt, what is a screw and what is a stud. And you'll draw 2 or 3 in the midterm exam. We give you the question will be generic, but it is different for each section, as well as the dimensions are different for everybody. So follow your dimensions and draw it.
Sorry, doctor, but can you repeat? I'm sorry.
What you said?
Can you repeat the last?
Yeah, what I said.
Which one we should draw?
for the assignment?
Yes.
Yeah, we have to draw all of them. All of them. We have to draw all 4 of them in the same page. All 4 drawings as it is. Just copy this page. And diameter is given 16. Major diameter. This diameter is given 16 for you in the question in the assignment. Okay, this is a drafting.
Okay.
Manual drawing. Also, it will help you to
Yeah, but
understand.
Teacher,
Yes.
there is
what
a
about
three.
the last
slide.
question?
Last question answer is like this.
Yes.
Like this answer for the last question. This is your answer for the last question. Okay, you have to draw it assembled together. Follow the dimensions from the question in the lab exercise, but it should be like this.
Teacher, repeat the drawing. Same this picture.
Yeah, same picture. This is the question. Answer to that question. This is answer to that question. Okay. Last
And
question. Question
then-
question 4. Question 4. This is the answer for question 4. Question 4. The question
But
is.
this one is not in the slide.
Question. It is not in the slide. This is exercise. Slide is for the theory part. This is the example for the assembly drawing, the simplest assembly drawing. This is a simple part, cylindrical part, which goes inside this rod. This rod goes inside, then put the quarter pin. The overall arrangement. See, you don't have to copy these parts as it is. Okay, you have to draw it like this assembly drawing. The part drawing is a question, assembly drawing is answer. So you have to make it like this. Okay. It is a work, but it is, you have marks for that, right? It is also try to use the instruments and draw proper drawing. Okay, they are saying here in the question, sectional front view and the side view. See here in this question, top view also is mentioned, but in our assignment we are not asking you to draw the top view. No need to draw the top view. Okay, this is not necessary to draw. We are asking you in the assignment question front view and the left side view. Okay, you don't have to draw the top view because it is mostly cylindrical part. It is similar. What we have in the front view is similar in the top view. We are saving some time and some space on the paper. Draw it and show the dimensions. So that's it for today. Next week we will start the next module. We are done with the module number 2. Also we'll have the quiz next week on the second module. Look at the assignment 2 and look at the slides for module number 2. Everything on that. Now those who came late, now
next
those
will be midterm exam.
Also midterm exam in the midterm lab session, like sorry, the midterm exam in the lab session. Suppose you have the lab on Monday, your exam on Monday in the same class. In the same class, we will upload you the question. You start drawing.
Theory week 7 or week 8?
It is not a theory. No theory exam for this course. Okay. Whatever theory part is there in, see, this is a drafting course. This is not a theory course. Okay. So this is a drafting course. Whatever lab we say, the lab means we are using the AutoCAD. The theory means we are not using the AutoCAD mostly. It's like sketches which you are making in the assignments or what we are answering, the understanding of the topics in the quizzes. So all your theory assessment is done based on the assignments and the quizzes. Okay. And all your lab assessment is done in your lab exercises, and that is a lab assessment. And then you have the midterm exam and the final exam using the AutoCAD. Lab means AutoCAD. No lab means you are drawing. It is related to drawing, but you are not using the AutoCAD for that. So there is no theory exam in week number 8 for this course. You finish your lab exam next week, and that's your midterm exam for 20 marks. Then you have the quiz in the theory class. The midterm exam, when you come for the lab session, suppose somebody is on Sunday, somebody is on Monday, whatever is your lab session, that time of the exam or just before the time of the exam, we will upload the question for you. And also you will get an email for the major diameter. This diameter value will be given to everybody by the email. You will check your college email for that. It is given in your email. Don't ask me. Don't ask me the value. Okay. you will get it in the email. If you ask me, okay, if you ask me, because only if somebody has a problem in checking his email, because already we have scheduled send the email for you. So you will get it in the email. Follow that dimension so that everybody has a different dimension. So that everybody has to at least to work on that on his own, do the calculation on his own, and you'll have some time like the whole day to submit it. It is not 1 week, okay? The whole day to submit it on the same day, and you'll have around 12 hours to submit, and it will be exactly 12 hours for you to submit, okay? From the beginning of your lab session. Suppose your lab is on some day in the morning 7 o'clock, then the same day night 7 o'clock you should submit your assignment. There is only one attempt, the lab midterm lab exam, there is only one attempt. So when you upload your file, check it and upload it. After that, no acceptance, no late acceptance. So don't try to be up to 7, try to upload as soon as possible. Actually in the same time you can do it at the time of the lab. Now anybody, if he has a problem with the like he doesn't have the ATO card or he doesn't have the laptop, you come to college, you tell me 1 day before the exam what time you want to come, and I will arrange the lab for you. You can come to the lab, but this should be done not at the time of the exam. You should tell me, like you can tell me now if somebody has a problem, so can I arrange for you the lab, and we can arrange to open the lab for you. If anybody want to come to the lab, tell me now, okay? You can come in the lab and do it. And I don't have the ATO card or I don't have the laptop, this excuse will not be accepted. And because of that, I could not submit. No, you can come in the college and you can use the college laptop and draw it. And college lab, we can use it, okay? If anybody is like that, tell me before the exam, at least 1 day before the exam. If it is, maybe today your laptop is okay, maybe later on. But if at the day of the exam is something is happening to your laptop, we are not responsible. If that is the situation, you come here in the college. Now those who came late for the attendance, please tell me your ID number.
144.
2